As part of our unit on probability and statistics, we're now going to be looking at collecting data. So the learning objective here is to be able to record and organise data that has been collected. Our success criteria is I can construct a table to organise data that has been collected. I can construct a stem and leaf plot to display data. And I can construct a dot plot based on the information within a given frequency table. So let's start with the frequency table or the frequency chart. The worked example tells us that it's the result of a survey of 30 students showing the number of people in their family still living at home. Draw a frequency table to summarize the data. So one thing you need to be very careful of is take a look at the data values themselves. Sometimes they'll be ordered, sometimes they might not be. And in this case, the numbers are definitely not ordered. There is no fashion of it going from smallest to largest or largest to smallest. So be very careful when you're counting your numbers. If you need to use highlighters or different colored pencils to strike out the numbers as you go so you know you've included them. If at this point you want to pause the video and fill in your own frequency table, feel free to do so and then compare your answers against the ones in the video. So I'm just going to quickly fill this out. So we've got a tally of 4 for the first one. 3. Then we've got 5. We've got 4 has 9. And 7. 1, 2, 3, 4. 1 and 1. So now looking at our frequency number, it's just going to be us writing our tallies, but just in number form. So we've got 3 here, 5 here, 9, 7, 4, 1 and 1. And what should happen is that the frequency, if we add them together, should equal the number of students surveyed. So you can see here that I've written this symbol, which this E-shaped looking thing, that's sigma. And what that means is that it adds to the sum of, it translates to the sum of, and the F meaning frequency. So the sum of the frequencies should be 30, and that's because we know that there was a survey of 30 people or 30 students. So now going on to construct our dot plot, we're going to take the data that we found from the frequency table and apply it to a dot plot formation. So if we, I've included the numbers here, try and make sure that it goes by an appropriate scale. You don't want to go from 1 to 50 and then to 70. Make sure that it is going in a very orderly fashion. So in this case, we're going up by units of 1. We've got no data for 1, so moving on to 2, we've got 3 families. And then for 3, we have 1, 2, 3, 4, 5. The next one we have 9. Then we have 7. Then we have 4. And then 1 and 1 for 7 and 8. It's really important as well that you do include a legend of some sort. So down the bottom, I'm going to write here that the numbers represent number of family members. And then what you can write as your chart title would be, you could write your chart title as frequency of number of family members. Doesn't have to be anything too long as your chart title and your axis title does reflect what the data is showing us. So if, for example, I showed my next door neighbor this dot plot, he can understand, or he'll be able to interpret that what it's telling us is the frequency of the number of family members in a group of students surveyed. And then he can look at the axis title and know that the numbers down the bottom, so the 1, 2, 3, 4, 5, 6, 7, 8, represents the number of family members living at home. So now if we move on, we're going to look at using data and then representing this in a stem and leaf plot. So stem and leaf plots represent information that is numerical. All data values are shown in stem and leaf plots, and there are two columns in a stem and leaf plot, so one being the stem, the other being the leaf. If we take a look at the worked example at the very top, so I'm just going to write that this is an example, you can see here that we're told the following stem and leaf plot shows the sizes of 20 students' DVD collection. So the title here is DVD collection, size of 20 students. So it's really important to include a title. We've been given a key here, so that 2 straight line and the 5. So the 2 is the stem and the 5 is the leaf. And that equals to 25 DVDs. Oops, DVDs. So if, for example, if we take a look at the first one, so we've got a stem of 0 and a leaf of 4, that translates to 4 DVDs. So that means that one student has 4 DVDs in their house. And if I pick another one at random, so I've got a stem of 5 and a leaf of 4 and 6, so that means that one student has 54 DVDs and another has 56 DVDs. So I've also included a little explanation where it says from the stem and leaf plot shown, the scores collected were, and I've included all the data. So what this tells us is that this is basically an extended version of the stem and leaf plot. So if you ever go back through the example and you have forgotten what the stem and leaf plot data actually translates to, you've got that little explanation there so you know you've done it correctly. So let's take a look at the worked example. So we're told the following scores represent the distance in kilometres travelled by a group of people over a particular weekend. The first thing that it tells us to do is to summarise the data into a stem and leaf plot. So with the stem and leaf plot, we definitely need a title. So I'm going to start with that first. So my title is going to be distance travelled, so nothing too elaborate. I'm going to have a key because that's really important. So remember, in the key, you're going to write your stem first and then your leaf second. So for example, I could say my stem of 4 and my leaf of 7 is the equivalent to 47 kilometres. And now I'm actually going to construct my stem and leaf plot. So I'm going to draw a line down the center of this. So I'm going to write stem here and leaf here. Now be very careful because what's happened is the data is not in any ordered fashion. It's not going from smallest to largest or largest to smallest. So again, if you need to use color pencils, highlighters, whatever it is you need to tick off your data so you know you've done it correctly. So looking through the given data points at the moment, the smallest number I have is 2 and the largest number I have is 105. So by the looks of things, I'm going to order my stem from 0 to 10. So I'm just going to write 0, 1, 2. Now, the line down the middle that you can see that's separating the stem and leaf, obviously you want it a lot closer or as close as you possibly can. So I might just fix that up. A little bit hard to do on the iPad, but that's all right. So I'm going to write stem here and then leaf here. So remembering that the line down the middle, so that's separating the stems and the leaves, is the equivalent to like 47 kilometers, for example. So I said the smallest number was 2, so the stem being 0 and the leaf being 2. And then the largest number we had was 105, so I wrote the 10 down the bottom and then 5 on the other side of the line. So now filling in my data points, I have 2 to 8, so that's 12 I have two 12s, and then I have an 18. So cancel my 12 out there, cancel my 12 there, and my 18. Then moving on to the 20s. So I've got 23, 23, and then 29. I have 34, 34, 34, and then 35, 38, and 39. I have 41, 44, 45, 48, 53, 54, and 58. So 63, 65, 67. I have nothing in the 70s. I have 87, and then I have 98. So you can see how I've written my numbers in a ascending order as well. So it's really important that when you do put your data into your stem and leaf plot, you go from smallest to largest. So I didn't write, for example, in my tens column, I didn't write 18 first and then 12 and 12. I wrote 2, 2, and 8. So that's 12, 12, and 18. So it's going in largest, smallest to largest. The second question says to comment on what the shape tells us about the distribution. So what you need to think about is that the distribution of data in a stem and leaf plot is either normal or symmetrical. So I'll just write that here. Or it's symmetrical. So if we look at, and actually this is probably really important to have written down somewhere, so if you can write this in your notes so you've got it with you always. So if we're looking at this particular stem and leaf plot, it's definitely not symmetrical. You can see that the data is a lot more skewed to people traveling shorter distances. So most people traveled between the 20 and 50 kilometer mark over the weekend, with only 3 people traveling over 70. So my answer for question 2 would be that the distribution is not symmetrical. So most people here (20 to 50 kilometers over the weekend) over 70 kilometers. So only 3 people traveled over 70 kilometers. So one traveled 87 kilometers, one traveled 98, and the other traveled 105. So that is all on constructing stem and leaf plots. And then also going back to frequency tables and dot plots. Again, make sure you've always, when you are constructing these things, you always have a legend, you have titles, so that if anyone were to look at this data and they didn't have the mathematical background, or they weren't able to break down what a dot plot or a stem and leaf plot is about, they should be able to, by looking at what you've presented, be able to identify what the data represents and be able to break down what you've presented. So for example, if it was your dot plot, and understand that it's all about the frequency as the dots themselves, and the axis down the bottom tells us whatever number it is that we're trying to represent. So in the case of our worked example, it was the number of family members living at home.